Hello students and my dear friends, I welcome you all to my channel. If you are watching my videos on regular basis and if you are not yet subscribed to my channel, then I highly suggest and request all of you to support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So this video is part of the playlist CBSE Mathematics Class 7 following the textbook of author RS Aggarwal. In this video, I am starting the new chapter, that is linear equations in one variable. This is part 1 of the series of videos. In this video, I will briefly discuss what is a linear equation with the concepts, background concepts required to understand what is a linear equation, and then we will understand what do we mean by the solution of a linear equation. This video we will not solve any problems. In the next video, that is part 2, I will discuss about how to solve a linear equation, that is how to find the solution of a linear equation. So let's get started with this video. Okay, so you have already studied equations in linear equations in one variable in your previous class, that is class 6. So you are already familiar what do you mean by linear equation and how do you solve a linear equation. But anyway, just for the sake of completeness, I thought of discussing it once again because in the textbook initially in the introductory part it has explained what is a linear equation and what is meant by solution of a linear equation. Maybe this video will be useful. You will get to learn a few extra things that you might not have learned in your previous class. Okay, so the textbook of RS Aggarwal, author RS Aggarwal, says that please follow the notes while I speak, that an equation is a statement of equality which contains one or more unknown quantities or variables. So an equation is a statement of equality, that is it is comparing the equality of two things, and those two things are nothing but some expressions having some variables. See in the note you can see it has the form algebraic, it has in the middle equality, and on the left hand side and on the right hand side it has some algebraic expression. The left hand side we call it as LHS, and the right hand side we call the algebraic expression to the left. I mean, whatever you see to the left of the equality sign, this is the equality sign. So we have the format of any equation in general is LHS equals RHS. Now what are LHS? Now LHS stands for left hand side and RHS stands for right hand side. Now actually these LHS and RHS are algebraic expressions. You have already studied algebraic expression in the previous chapter. I have already covered the chapter algebraic expressions thoroughly. If you have not watched those videos, I highly suggest that you first watch the videos on algebraic expression, then you will have a better understanding. So both the LHS and RHS in the equation are algebraic expression, and algebraic expressions are nothing but addition or subtraction of terms, where terms are products of constants and variables. Okay, so this is the general form of an equation. So in the notes you can see some examples of equation are given. They have the first equation has one variable, that is x. The second equation has two variables, x and y. Third equation also has three variables, x, y, z. Fourth equation has one variable, x. Similarly 5 and 6th. There are some examples you can take. So while I am speaking and discussing, you can pause the video and take screenshot of the notes if you think it will help you. So this is in general what an equation is. So we have in the middle equality sign, and to the left and to the left side and the right hand side we have some algebraic expressions. So we are basically saying that the algebraic expression in the left hand side is equal to the algebraic expression to the right hand side. Okay. Now it says, the book says, as per the definition, linear equation is an equation involving only a linear polynomial. Okay, so now it is defining what is a linear equation. So linear equation is having the form, it's having a similar form like the equation. We have LHS equals to RHS, but here the LHS and RHS should be linear polynomial. So now we need to understand what is a linear polynomial. To understand what is a linear polynomial, we need to first understand what is a polynomial. So a polynomial is an algebraic expression with variables having non-negative integers as powers or exponents. So as an example, you can see there are three polynomials where all the variables have powers which are non-negative integers. Non-negative integers means powers can be 0, 1, 2, 3, 4, like this. The powers can be whole numbers. Non-negative integers means whole numbers. So this is a polynomial. A polynomial is an algebraic expression. So I am in short writing P as polynomial. So polynomial could be any algebraic expression, but the variables, it can have any number of variables, but all the variables should have non-negative integers as powers. So this is a polynomial. I am just giving an example. 2 is a polynomial. How come 2 is a polynomial? We can say that 2 is nothing but 2 into x to the power 0, and x to the power 0 is valid because its power is 0. So okay, so 2 is nothing but, we can write it as 2 into 1. We can always write it as 2 into x to the power 0. So this is a valid polynomial. Here the power, here we have only one variable x and the power is 0, and we know that any number, any non-zero number to the power 0 is always 1. So this is a polynomial. Another one could be, say, z cube y x square minus x cube. I mean, wherever you see variables, the variables must have a power or exponent which is a non-negative integer. That is the integers 0, 1, 2, 3, 4, like this. So I hope it's clear what is a polynomial. Now we need to understand what the term degree of a polynomial. What is the degree of a polynomial? Degree of a polynomial is, you consider the sum of exponents of all the variables in a term. You consider all the terms in a polynomial. So polynomial is nothing but an algebraic expression where we have one or more terms. Now that term could be a constant term, or it could be a term having variables, like one or two variables. So in all the, you consider all those terms where it has variables, and you sum the powers of all the variables. Whichever term has the highest sum of the powers, that sum is the degree of a polynomial. In the example, you see the first one, x cube minus xy plus 2. It's a polynomial of two variables, x and y, and we see that the first term, x cube, it has the power 3. It has only one variable, it has the power 3. And the second term, minus xy, the powers of x and y are 1, 1. So if we add them, 1 plus 1 equals to 2. So the highest power is 3. So in this case, the degree of the polynomial is 3. Similarly, in the second case, x minus yx plus 9. In this polynomial, the second term, minus yx, the variables are y and x, their powers are 1 and 1. So the sum of their powers is 1 plus 1 equals to 2. So that is the highest power. That is the highest sum of powers. So the degree is 2. Similarly, you can understand 3, 4 and 5. So that is the degree of a polynomial. So let's say I am considering a few more examples. Let's say a polynomial x y square minus y cube plus z square and x square. what will be, this is a polynomial in 3 variables x, y, z, and why polynomial? Because all the variables have powers, exponents as non-negative integers. Now what will be the degree? I mean short writing d as degree. What will be the degree? The degree will be, you look at the term which has the highest sum of powers of the variables. What is the sum of powers for this term? What is the sum of the powers of the variables? It is 1 plus 2 equals 3. What is the sum of the powers of the variables in this term? That is minus y cube. It is 3. And what is the sum of the powers of the variables in this term? That is the z square x square. It is 2 plus 2 equals to 4. Hence the degree is 4. The maximum sum of powers, the degree is 4. Let's take another example. Let's say x square y square minus x cube plus y x square and minus y, let's say cube x square. So this is a polynomial in 2 variables x, y, and what is the sum of powers of the variables in this term? First term, it is 2 plus 2 equals 4. What is the power of the variables in the second term? That is minus x cube. It is 3. What is the power? So what is the sum of the powers of the variables in the third term? That is y x square. It is 1 plus 2 equals 3. And what is the sum of the powers of the variables in the fourth term? That is minus y cube x square. It is 3 plus 2 equals to 5. So the maximum sum of powers is 5. So for this polynomial the degree is 5. So I hope it's clear what is the degree of a polynomial. Now what is a linear polynomial? So a polynomial with degree 1 is known as a linear polynomial. It's very simple. You can see from the example that x plus 4 the degree is 1 because the only term with variable is x, and x means power is 1. Similarly minus 9x the only term with variable is x, it has power 1. Similarly 3x by 4 plus 2 and y minus 2, they are all polynomial with degree 1. Now also note that, so I am in short writing linear polynomial as LP. These x minus y, this is also a linear polynomial. Why? Because the degree of this polynomial is 1. Why? This term has the sum of powers 1. This term has the sum of powers of the variables 1. So degree is 1. But this degree is 1. So this is also a linear polynomial, but it has variable 2. Similarly y by 2 minus x plus 2. This is also a linear polynomial because because the degree is 1. Degree is 1. Any polynomial that has degree 1 is known as linear polynomial, irrespective of the fact how many variables it has. The degree should be 1. So that is linear polynomial. So now you can understand. So now that you have understood what is a linear polynomial, now you should understand what is a linear equation. So linear equation is an equation involving only linear polynomial. So linear equation. So now if we consider what could be a linear equation, examples of linear equation. So see the examples of linear equation. The first one says x plus y equals to 0. X plus y, this is a linear equation. Why? On both the side, equality of both the side, left hand side and right hand side, LHS and RHS both are linear polynomial. X plus y, we already know it's a linear polynomial. How come 0 is a linear polynomial? 0 could be written, 0 any constant term is always a linear polynomial, because 0 equals to, we can say 0 into 1, and I can always say 1. I can always represent 1 as x to the power 0. So it has a variable, but the power is 0. Since we know that a linear in a polynomial, the powers of the variable can be should be non-negative integers. That is they can be 0, 1, 2, 3, 4. So x plus y equals to 0 is a linear equation. That is both LHS and RHS are linear polynomial. Similarly, 3x by 4 minus 1 equals to 3. Obviously, this is also a linear polynomial, and y minus 3 equals to 2 minus y. So y minus 3 equals 2 minus y. This is also a linear equation because y minus 3 is a linear polynomial and 2 minus 3 is also a linear polynomial. Now, please remember that one thing to note, that in an equation, this is important to note that we said in the general definition of an equation was LHS equals to RHS, where LHS and both LHS and RHS are algebraic expression. So if I consider this x cube equals to x cube, is this an equation? As per the definition we have discussed so far, both the left hand side and the right hand side are same, they are both algebraic expressions, so it should be a equation, but it is not an equation. This is not an equation, this is an identity. You will learn perhaps algebraic expressions and identities in some other chapters or in future classes. Not an equation, but is an identity. Why identity? Because both the LHS and RHS are the same expression, have the same expression. Similarly 2x minus 1 equals, if I say 1 minus 2x, this is also not an equation. This is also not an equation. This is an identity, because if you simplify, both the LHS and RHS are same algebraic expressions. Now, so what exactly is the difference between an equation and an identity? Why do we at all use an equation? We use an equation. Equation is used to solve for a variable, to find the value of a variable that satisfies the equation. We will discuss a little later on regarding the solution of a linear equation. Now, so this is not a equation, this is an identity. This is also an identity. Similarly, let's say x square plus y square plus 2xy equals to x plus y multiplied by x plus y. This is also not an equation, this is an identity. Okay, so I'm sorry friends, it is thunderstorm, it is lightning and thunderstorms, it has started. I have to unplug some switches, so please give me a minute. Okay, I'm sorry for some delay. So now we were discussing that this is a equation. This is not an equation, actually this is an identity, because if you see both the algebraic expressions on the left hand side and the right hand side, they are same, because if you simplify, this is a product of two monomials. If you simplify, this will come out to be x square plus y square plus 2xy, and this is exactly the same as the algebraic expression to the left hand side, LHS. So that was some thing to keep in mind, difference between an equation and an identity. Even though they may look same, but I mean the structure is same, but if the algebraic expression on both the sides are equal, same, have the same structure, then that is an identity. Okay, so now we saw examples of linear equation. Now, so linear equation is what we have. It is of the form LHS equals to RHS, where both LHS and RHS are linear polynomial. Now, the linear polynomial can have any number of variables, 1, 2, 3, 4. So, in this chapter, we will be learning about linear equation in one variable. So, in the linear equation, if the linear polynomial has only one variable, that is what we call it a linear equation in one variable. So, in the examples in the notes, you can see x by 4 plus x by 6 equals to x by 2 plus x by 3. So, we have only one variable considering both the LHS and RHS. So, examples are, you can already see some examples in the note. I will discuss some more examples. Let's say, so linear equation in one variable. We must have one variable. So x equals minus x equals 2. This is a linear equation in one variable. Again, x by 3 minus half equals 1 minus x by 2. This is also a linear equation in one variable. You see, there is one variable and both the LHS and RHS of the equality sign are linear polynomial. That is a polynomial with degree 1. All the variables, first of all, note that we are only dealing with one variable. So that variable will have power 1, nothing else. So that is a linear equation in one variable. Okay. Now, what do we mean by solution of a linear equation? Solution of a linear equation. Okay. So the definition in the book says the value of the variable that makes a linear equation a true statement is called the solution or root of the equation. So let's take an example. Let's say we have a linear equation 4x minus 3 equals 1. We are having this linear equation, and we need to see what value of x satisfies this equation. What is meant by satisfies this equation? If we put that value of x in this equation, then the LHS and the RHS should be equal. That is, in this case, the LHS should come to 1. Now, what is happening? So LHS for this equation, LHS, I mean the left hand, the algebraic expression to the left hand side of the equality sign, LHS for x equals to, let's say 1, is 4, 1 minus 3, that is 4 minus 3, that is 1, equals to RHS. So we see that when we put the value of x in the equation 4x minus 3 equals to 1, that equation is coming to be a true statement. That is, it is true. What is meant by that equation is a true statement? It means simply that the value of the LHS is equal to the value of the RHS. So by putting the value of x equals to 1 we see that LHS equals to 1 and also the RHS is given as 1. So x, this implies x equals to, we say that x equals to 1 is a solution. It is also known as root. Both the word means the same thing, is a solution or root of the equation, rather linear equation 4x minus 3 equals to 1. Now, for a linear equation in one variable, there will only be one value of the variable that will satisfy the equation. There cannot be more than two values, more than one values of the variable that will satisfy the linear equation. Keep this thing in mind. So that is, this is what we mean by solution of a linear equation. The process of solution of a linear equation means what value of the variable in the equation satisfies the given equation. Now, what is meant by satisfies the given equation? It simply means the value of the LHS will be equal to the value of the RHS when we substitute the variable x for that value. And then if the LHS is equal to RHS, then that value of the variable is known as the solution or root of the equation. And the process of finding that value of x that satisfies the equation is known as solving the linear equation. So you can take screenshot from the notes. I have some notes. Okay. So that was all to discuss about what is meant by a linear equation and what is meant by a solution of a linear equation. So we will not solve any problems. There is nothing to solve. I just wanted to discuss the concepts. So I hope this video was beneficial to get an introduction of what is a linear equation is and what is meant by solution of a linear equation in one variable. And in the next video, I will start discussing how to solve a linear equation, which you have already studied in previous class, but still I will discuss the rules or methods to solve a linear equation in one variable, and we'll solve some problems from the exercise 7a. So once again, thanks for watching, and if this video was beneficial, then please like it, share it with your friends, and also please do not forget to if you are not yet subscribed, then please subscribe to my channel, support me so that my channel can grow, and I will get motivated to come up with this kind of videos on regular basis. So that is all for today's video. Thanks for watching, and until the next video, take care and bye.